Acha, so we have discussed trigonometry, the solving part of the trigonometry using identities to prove the questions, whatever that they've given you, left hand side is equals to right hand side, and then solving trigonometric equations using the cast and the alpha and placing them in the correct quadrants and then getting the final solution. This part is properly we've done the past papers as well, so hopefully this is not very much of an issue. The problem arises when we move on to the graphs of trigonometric ratios and their graphs and transformation as well. So not only the graphs of trigonometric but their transformation. For example, this graph is of only sine x. This is the most basic graph. So if we have sine 3x, if we have 2 sine x, or if we have sine x plus 5, when you have different transformations applied to the sine function, how your graph would change, how your shape would change, how the graph will move. So the first of all, the thing is that these are the three we know: sine, cos, and tan. The three basic trigonometric ratios: sine x, cos x, tan x, and all three of them are periodic. Periodic means that they are repetitive. They will repeat themselves again and again. For example, this is one wave. You can say sine wave. This is one sine wave. And the next part, if you want to continue, it will be the same, like the same sine wave. It will continue. Then again, it will continue. So periodic, it will keep on repeating itself. It is never ending. If you move on to x positive infinity, this graph would move on the same way. Similarly to the negative side as well, it will keep on moving with the same uh, this shape. So period is what? The one period of sine is it completes in 360 degrees. You can see it over here. The sine x one period is the interval for one cycle, one wave. So the interval of one sine wave, it is 360 degrees sine x. Similarly for cos as well, it starts from one and then goes, this is the one cycle, and if you want to continue, it will keep on continuing as it is, like this, the same shape. So the sine and the cos are very very similar. You can see the shape. If you continue them, they are very similar. It will also be like this, it is also like this, and the difference we will discuss. Then tan graph as well, this is very unique, different than the sine and cos, and this will also continue, keep on continuing like this. Asymptote, I think we have discussed them before as well, but this is also repetitive. So periodic graphs. So period of sine is 360 degrees. Okay, it completes one cycle in 360 degrees. Cos also, it completes one cycle in 360 degrees. But tan completes one cycle in 180 degrees. This is one cycle from here till here, and then you can see this is continuing again. We are just repeating the same shape again. If you want to repeat, it will go up like this, come down again. So this is another cycle. So the tan cycle comes. So look over here. Period is 180 for tan. Then if we go on further, the sine graph, it starts from 0. Look, I have first of all done what? These are the amplitudes, 1 and -1. This is the maximum your sine can go. The -1 is the lowest your sine can go. -1, this is this point, and +1 is this point. And then the sine starts from 0, and you can see there are 4, 1, 2, 3, 4, 5 division. It is at 0, it is at 90, 180, 270, and 360. So after 0, there are 4 divisions: 1, 2, 3, 4. And on these 4 or 5, these divisions, the points, you have the exact values that you can plot them easily on the graph. So you can see sine 0, when the value of x is 0, the value of y will also come out as 0, because sine 0, you can see it is, the y value is 0. Similarly, if your x value is 90, so sine 90 will be, y will be equal to 1 when your x is 90. Similarly, sine of 180 will be 0, sine of 270 will be -1, and sine of 360 will be again 0. You can use a calculator as well. You can show them, look, sine 90. It is what? 1. Similarly, if it is sine 270, it is -1. So the calculator also follows this graph. Okay, so these are the 5 points. These points are very important: 0, 90, 180, 270, 360. These can give you special points which you can then plot and then join them to get a smooth curve. So that's why you have now, it starts from 0, then goes maximum. This is the maximum. Then again 0. Then this is minimum. Then again 0. So there are 3 zeros and 1 maximum, 1 minimum. This is what is making a simple, basic sine x graph. And you can see the period is 360. So this shape is important. These points which I've plotted, the 4 divisions which I've made, these are important. And you have to learn this. Learn the basic shape, and then we do transformations on this one to get new graphs. We will see those as well. Then the next one is cos. Cos and sine are very similar. If you would just move the sine one over here, this point, if it starts from maximum, then this would be your cos. Look, the cos graph is starting from maximum. And again, same 5 points: 0, 90, 180, 270, 360. And but the thing is, the difference is it is starting from maximum, then 0, then minimum, then 0, then maximum. And then you join them with a smooth curve. Whenever you would sketch them as well in the exam, make sure you do them very neatly. Your divisions on the x and the y, they should be very reasonable and equal divisions. And the shape of the graph, the curve that you're making, that should also be very smooth, so that it is understandable where it is passing. These points, the turning points, the maximum, the minimum, and the zeros, all of these are important to show in the exam. If they will ask you to draw something, if they ask you to show this, or if they are asking you to draw the sketch of this cos x, so you will draw this exact same thing. Everything is right now included, the exact points as well, the interval as well, the period as well. It is from 0 till 360, and the maximum and minimum as well. Maximum is 1, minimum is -1. So for the cos x and for the sin x, the maximum is again 1, minimum is -1. It's the same. They both are very much closely related. Look, the last one is very different. This is tan x, and I can actually show you. I can actually prove you why do you get this tan graph like this. It's different from sin and cos using the identity that we had. Over here, the tan, over here we don't have any maximum or minimum because the graph can go as much high that we want it to go. As we know, this is an asymptote. Asymptote is what? Where a graph will never cross this error line. This is your asymptote. This is always at multiples of 90. 90, not 9 multiples of 90. Look, 90 and then at 270, then it would be at 540. Okay, like this. I'll show you. I'll write down the formula where you will get the asymptotes. So, and there is no maximum or minimum. It will keep on going up, following the asymptote up until infinity, vertical. And it will start from the very lowest, from negative infinity, and follow the asymptote, and then join this 0. This is one interval from 0 till 180. So the period of tan is 180. Don't forget this. This is different. Sine and cos have same period. Tan has a different period. It always completes at 1 cycle and 180 degrees. But over here as well, you are plotting, look, the same 5 points. 0, then you have 45. Not the same, but slightly different. 0, and then 45, then 90, then 135, and then 180. Over here, the division you can see it is of 45, 45, 45, 45. I will tell you why. And then it is starting from 0, then it is 1. 1 at 45. Rayan is here. Rayan, can you hear me?
Sir.
You called me right now?
Then you pressed it. My bad.
Okay. No worries. Okay. So for tan graph, it has a exact value at 45. The maximum that you had over here for sine, you can see it is at 1. So the same one value you will get when it is 45. So tan 45 will give you 1. Tan 135 will give you negative 1. You can see it in the calculator as well. Tan 45 is 1. Tan 270, it is asymptote. Look, complex infinity. 270 is this vertical line. And this is asymptote. So no solution at 10 through 70. Tan 90 will also no solution. Complex infinity. Tan 135 is negative 1. You can see everything. So you can use your calculator as well to get the points, exact points. If you in the exam, if you forget something, you can use your calculator. You people also know. Sanchi knows about the function of the table function. Rayan also knows the table function. It can help you get the points of the graph at different intervals. I will tell you as well. So this is a very important topic. Okay, this is a very frequently asked question to draw the sketches of different types of cos or tan or sine. So you should be very well prepared for this question. Sometimes they're difficult as well. So that's why this you have to learn these three diagrams by heart properly. Ratta. Then how can you relate this cast over here? You can see in the first quadrant we know that all values of the trigonometric ratio they are positive. So you can see in the first quadrant the angle ranges from 0 till 90, right? 0 till 90 degrees. So we can see from 0 till 90 the graph of sine is also positive, the graph of tan is also, sorry, cos is also positive, and the graph of tan also positive, isn't it? So if we have any value of x which is between 0 and 90, this value, your y value always comes out as positive over here as well, over here as well, you can see, and over here as well. Your y values are all positive between 0 and 90. Do you get it? समझ आ रहा है अभियान? That's why you have the values of all of the trigonometric ratios positive in this first quadrant. Sanchi, Rayan, Mohit.
Ji, sir.
If you move on to the second quadrant, look, we know that only sine is positive. In the second quadrant, the angle ranges from 90 till 180. So in the 90 till 180, you can see only sine graph is positive. Over here, between sine 90 and 180, your cos has become gone in the negative quadrant. Look, sorry, negative y-axis. So your cos value will be negative. Your tan value is also negative. Look in the second quadrant. So that's why only sine is positive in the second quadrant between 90 and 180. Between 180 to 70, only tan positive. So you can see between 180 to 70, tan is positive in the above positive y-axis. This is also negative. This is also negative. Negative, negative. Only tan is positive. And the last quadrant, fourth one, only cos is positive. You can see both of the other graphs are below the x-axis. This is also below x-axis. This is also below x-axis. Only cos is above. So cos values are all positive in the fourth quadrant. Nothing else. So this using these graphs, we are getting this cast. Okay, this is the background. You people should copy this down, take a screenshot. All of this is important over here, and then we'll do some transformation on this thing. I'll tell you. I'll give you 2-3 minutes, or take a screenshot, or I'll share you the notes later on as well. And properly draw these graphs on as in your notes as I have drawn it over here neatly, straight lines, proper curves, plotting the proper points. Okay, so now we will do the transformation on these trigonometric graphs, and you will see how we would change things. So now this is transformation. A transformation, the generalized format that we can follow, it is something like this: y is equals to a, whatever your trigonometric function is, b x plus c plus d. So how many constants we have introduced? 1, 2, 3, 4. So if you have any value of these constants in your equation that they will give you, your graph will somehow change a bit. So what does each thing do? A is your amplitude. If the people who had physics in O levels, they know about amplitude. Amplitude is the minimum or the maximum distance from mean line. B will help you to find period. Period, the interval for one cycle. One cycle or one, what was the one wave. C is your horizontal translation. Horizontal translation or left right movement, you can say. How much it will move in the left, how much it will move in the right. It depends on the C value. If your C is 0, then it won't move in the left or right direction. It would be the same as them that we have drawn previously. Then your D. D is your vertical translation, up, down. But the better way to understand this D is your D will also be called, can also be called the principal axis. Principal axis or the mean line. And you will see how each of them would now make the difference. Okay. So first of all, I am making a graph of, I will do, we are all sketching, okay? Y is equals to, let's suppose this, it is 2 sine x. So just after comparison with the thing that I gave you this general format, you can see that your only a value has changed. So your a is right now 2, the amplitude is 2. Otherwise, your b is 1, your c is 0, your d is also 0. There's nothing being added outside. D is outside the trigonometric function being added. So there's nothing being added. So D is 0. Nothing is being added inside with x. So C is also 0. And the coefficient of x is your B, you can see. And the A, coefficient of the trigonometric function actual, sine x, it is your A. Now, what do you do? Step number 1. Draw the principal axis. Principal axis. And principal axis will be y is equals to D, which in this case right now is y is equals to 0. So this means the y is equals to 0 is what? That is the x-axis. So x-axis is your principal axis right now. Then I will just right now dotted line. We can see this is your principal axis, mean line. Y is equals to 0. Second step, find period. For the period, the formula for sine and cos, it is 360 upon b or 2 pi upon b. If it is in radians, then you would use pi, okay, 2 pi. So 360 upon b or 2 pi upon b. And when if it is tan x, the graph of tan, then it would be 180 upon b or pi upon b. You have to learn this as well. So in this case, right now we have sine. Yes. So it would be right now the period will be 360 upon 1, which is 360. So in this case, right now, for 2 sine x, your one cycle will complete in 360 degrees. And what do you do next? With this period of 360, you always divide whatever the period that you get, you divide it into 4 divisions. So that will come out as 90. and then you will plot these four divisions. So it will start from 0, then it will be 90, then it will be 180, then it will be 270, then it will be 360. So look, the division which I found, 360 divided by 4, and then I plotted the four divisions like this. The four divisions which you drew over here. Look, 0, 90, 180, 270, 360. This is how you got it. So you plot this as well. Third step, amplitude. We can see your amplitude is right now 2. So amplitude is the from mean line plus minus a. Okay. If you do plus a, you will get the maximum. If you do minus a, you will get the minimum. So mean line is 0. So 0 plus 2 will be your maximum. 0 minus 2 will be your minimum. This is your amplitude. Then plot exact points that we know from the original graphs, and join. So exact points from the original graph, we knew that the graph of sine starts from 0, then goes maximum, then goes 0, then goes minimum, then goes 0. This is how the graph of sine goes over here. Look, 0, maximum, 0, minimum, 0. So that's what I have plotted over here as well. 0, maximum, 0, minimum, 0. And then you will join them with a single smooth stroke. This is difficult over here on my screen to draw sketch this curve smoothly. So it should pass through the points, okay? That's why I draw them dotted, okay? You will draw it single, solid stroke, okay? Not dotted. This is your graph. So look, the only difference in this graph is the amplitude has changed. Otherwise, everything is the same as the basic sin x. So I've given you the steps. Follow these steps properly, and you can then plot anything that they have given on over here. We'll do more examples as well. This is the most easy one, I think, that I've given you. You can take a screenshot. I'll give you the notes. The next one, I'll do 3-4 examples, and then you can copy them down later as well. Right now, focus on the understanding. Second one, we have y is equals to sine 2x, sine x. If it is y is equals to 3 cos x minus 1. So first of all, the step 1 was draw principal axis. Principal axis right now, you can see the thing which is being outside added. A is 3, B is 1, C is 0, and D is minus 1, the thing which is outside being added. So that is your principal axis. So it is, draw a dotted line at y is equals to minus 1. This is minus 1. This is your mean line. Second step, find the period. Was it? Yes, find period. So period is, again, I told you, period is for cos and tan, it is same. Period is 360 upon b, which is right now 1. So 360, and then divide the period into 4 divisions. That is 90. So 90, 180 equal sized division. Then amplitude. Amplitude is, I told you, plus the mean line minus the mean line. So amplitude is 3. So minus 1 plus 3 is 2. And minus 1 minus 3 will be minus 4. So maximum is 2, minimum is minus 4. And what more? Now it is the graph of cos. The basic cos graph goes from maximum 0, minimum 0, maximum. The same thing you will do over here. It will start from maximum, which is this 2, then 0 at the mean line, then a minimum, then again 0 at the mean line, then again maximum at 360, and then you will join them with a smooth curve like this. Any questions, anyone? समझ आया? First step, mean line. Second step, period. Third step, amplitude. Fourth step, plotting, and then joining. Let's do another one. Y is equals to tan 3x minus plus 1. Let's suppose. Your amplitude A is 1, your B is 3, C is 0, D is 1. After comparison, then principal axis is y is equals to 1, so that will be your dotted line. First step done. Second step, period. Period formula for tan, it was 180 upon B, so it will be 180 upon 3, which will be 60. And then I told you divide this new period by 4, so you will get 15. So now 15, 30, 45, 60. And then amplitude is 1, so from 1 go 1 up, so this would be 2, and 1 down, so this will be 0. These are the exact points. Then the graph of tan, it starts from 0, then 1, then positive infinity. 0, 1, positive infinity, then coming from negative infinity, 10, minus 1, and then 0 again. So 0, 1, the exact point that we found at the second division, then it is infinity, then coming in from below, passing through the minimum, which is minus 1, not minimum, and then again 0. So your graph will be something like this. This is your one cycle of tan. This is how you will draw it. Okay, एक और करें. Let's do y is equals to 4 sine 2x minus 3. All three of the things combined. The question in the exam, they won't be as complicated. Okay, so don't worry. I'm just combining. I'm doing the more difficult part with you, so that you people understand the easier ones yourself as well. Okay, this type of question, itna zyada complicated, they won't give you to you. They will either give you A or B, or they will give you B or C, or they will give you A or D. Any two of them. Okay, maximum. I haven't seen anything where they have combined everything all together. So don't worry about it. It will become very complicated otherwise. Okay, so in this one, the first step, first of all, identify A, B, C, D. So A is 4, B is 2, C is nothing, being nothing added, and D is minus 3. Start with the minus 3, always. I'm moving it slightly above because I know the graph will be below the x-axis. So at -3, this is your -3 dotted line. Then period is the formula for sine. It is 360 upon b. So 360 upon 2, it is 180, and then 180 divided by 4, it will be 45. So 45, 90, 135, 180. Then amplitude is 4, so -3 plus 4 will be 1, and -3 minus 4 will be -7. -7. And we have plotted everything, and this is sine. So we know the sine starts from 0, then goes maximum, then 0, then minimum, then 0. So 0, maximum, 0, minimum, 0. This is your graph. It's better if it is smooth, but the points, they are more important to show that where it is passing through. What is the maximum? What is the minimum? Any questions, anyone, on this one?
No, sir.
Okay. If it is y is equals to uh, 210 x minus 30. Okay. Now there's something being added inside. So now you can see your a is 2, your b is 1, the coefficient of x, your c is -30, and your d is 0. Your nothing is being added. So now this is some new thing. This is new when your c is not 0. So what happens? This is horizontal translation. I told you, horizontal translation. If it is negative, if your c is negative, you move in the right direction. Opposite. If your c is positive, you move it in the left direction. Opposite. So we will start off first of all again with the principal axis, which we can see again it is 0. Principal axis is the y is equals to 0. And then the amplitude, sorry, the period. Period is 180 upon 1, which is 180, and then divided by 4, so 45. So 45, 90. Now look what will you change, okay? Now this is the important part. 180, sorry, 135, 180. And amplitude is 2. So it will go from 0 till 2 and 0 till -2. If we draw it right now, we know it would be asymptote over here, and it will be point this, these would be the point passing like this from 0 to this point, and then coming in from negative infinity to this point, following this point, and then joining it at 180 like this. This is the graph when we did not have any -30. Okay, when we did not have any c, forget about the c, this would be the graph. Now if I want to incorporate the effect of c over here, what will I do? We know that the c is -30, and I told you when it is negative we move it to the right side. So this means that my entire graph will move 30 units to the right. So this means what will happen to this point? This is 0. This will move 30 to the right, so this will become 30. 0 will become 30. 45 will become 75. 90 will become 120. And 135 will become 165. 180 will become 210. And so the graph will be like this. This would be passing from here, then this, then it will be asymptote at this point, not 1 9. Now it will be at 120, and then this point and this point. So now the graph will be something like this. This is your graph. How can I show it to you? Let me bold it. This is the asymptote now, and it is passing through these values: 30, 75, 120, 165, and 210. If you want to continue, it will continue like this. It will go in like this, right? If you want to continue it on the left side. समझ आया? So what do? You first of all sketch it the usual way, just like and then you would move the complete thing to the right side or to the left side. In this case, you have to move it to the right side. So you will then erase. You will then ignore the previous graph. This part, forget about it. This is not your solution. This is your graph. Everything has moved to the right side. And in the exam, if they ask you to draw the sketch from 0 till 180, so you will keep the graph till here, till 180. Okay, not till 210, and it will start from here. This would be the graph then, from here till here, from 0 till 180. So it depends also what part are they asking you to show. Okay, if they ask you to show from 30 till 210, it will be a complete same thing, asymptote in between. If it is from 0 till 180, then you will repeat it on the left side as well, and then you will keep it from here till here. This would be your graph. समझ आ रहा है? Any questions, anyone? I can show it to you on the Desmos as well. We will continue this again. I know this is difficult a bit. 10x minus 30. 30, they don't take 30. This usually works in radians, so pi by 6. So look, the graph is again. Why is it zooming in? Slightly to the right side. Otherwise, if I forget about this 30, to 10x. So look at the blue graph. The blue graph is the 1030, and you can see the complete graph has moved 30 units to the right side, pi by 6 to the right side. Okay. This is the graph we have just drawn. सही है? Any questions, anyone? We will do more practice on this thing. We will do more graphs on this. But right now, this is a very important part. Revise this again and again and again and again, and redo all of the graphs which I have done for you, so that you can Memorize this. This is something you need to memorize and then practice a lot so that this inculcates in your mind. Otherwise, you will forget it. I am telling you right now, you will forget it because every year people struggle on this. Okay, I'll share you these notes as well. Stopping the recording.